All right, so we're going to be converting 3/4 into a decimal point. So if you type in the calculator 3 divided by 4, you are going to get the answer 0.75. Okay, you just divide the top one by the bottom. So 3 divided by 4, and you get your answer. So in this one, 4 and 2/5, you have a whole number and a decimal point. So if you first you put the 4 in the front, so you know the 4 goes in front of the decimal point, and then 2/5, if you do 2 divided by 5 in the calculator, you're going to get 0.4. So now you know what goes behind the decimal point. So what goes behind the decimal point is a 4. So you're going to write over here the 4 behind the decimal point, and you're done. Next one, let's scoot this up here as much as we can so I don't have to scoot all the time. Okay, so convert 0.3 into a fraction. So now we're doing the reverse. So 0.3. So this will be written as 3. So whatever's behind the decimal point goes in the numerator. Then the amount of numbers behind the decimal point go in the denominator. And that's why this is called 3/10. Now let's do this next one. So 25 is going to go in the numerator because it's behind the decimal point. And then there are 2 numbers behind the decimal point. So this is going to get 2 zeros behind the 1. So that'll be 25 over 100. All right, let's scoot a little bit more. And now we're at turning 3.21 into a fraction. So 3.21, so 3 is the whole number, so it's going to go in front. 21 is the decimal point, so that's going to be in the numerator. And because there are 2 numbers behind the decimal point, it's going to have 2 zeros. 3 and 21/100ths. All right, let's get a little bit more crazy here. So 2.8, and 8 is repeated. So 2 goes in the front. That's starting to get easier, right? And then the 0.8. So this is 0.8888888 forever. So how do I convert that into a fraction? So 8 still goes in the numerator because that's the number that's repeating over and over again. And what do we put in the denominator to make it repeat? A 9. Pretty simple idea, but that's all you have to do. All right, so let's go back to the next page here. Let's do this one here. So convert 1.15 into a fraction. So this is repeating 1/5. So 1/5, 1/5, 1/5, 1/5, 1/5 forever. So the 1 goes in the front because it is the whole number. And then this right here will turn into 15. And how many numbers are repeating over and over again? 2. So this is going to get 2 9s. So the 9s make things repeat. You use zeros when it terminates. Okay? So let's talk about rational and irrational numbers. So first, let's talking about all the numbers that are rational. So we have natural numbers like 1, 2, 3, 4, 5, 6, counting numbers. Then whole numbers adds zeros to it, so now we have zeros, right? Then we have integers. Integers add negative numbers, so we still have no decimal points. We just have negative numbers, negative whole numbers, and counting numbers. So integers includes everything inside the box. See how it encompasses everything? So the last one is rational numbers. And that includes some of our decimal points, right? So rational numbers are anything you can turn into a fraction. Okay, so that includes integers, whole numbers, natural numbers. All of this is included in rational numbers. So rational numbers includes any decimal point that ends or terminates, and it includes any decimal points that repeat. Okay, so repeated decimal points that end, integers, whole numbers, natural numbers, that's all under the umbrella of rational numbers. Now over here, for me, there's 3 categories that give you irrational numbers, numbers that cannot be turned into a fraction. The first one is the most common one is pi. So anything with pi will produce an irrational number. It goes on forever, never repeats, okay? So it's irrational. So another one would be a square root you do not know the answer to. So like the square root of 20 does not have an answer. So that is irrational. Any square root you do not know the answer to is irrational, and anything with the pi symbol is irrational. Now the last one is decimal points that go on forever but never repeat. So let's say I have 2.813479, and then I put the dots telling you it goes on forever. There is no repetition here. This is irrational numbers. It goes on forever and never repeats. If I write 2.8181118111, now there is a pattern here, but it is not repetitive. So it is also considered irrational. So that's it. Good luck.